Brovelli.
Okay, so good afternoon, everyone, and welcome to this webinar. I'm very happy to have the possibility of introducing to you Professor Taichi Furuhashi, because it's a person that I admire so much. We have known each other since many years now, and I had the opportunity also not only of speaking with Professor Furuhashi during conferences or meetings and so on, but also of doing a mapping party together when we were in Osaka. I remember that the point was to do this collaborative mapping for building the resilience map of the city. And it was a fantastic experience. Every time I'm speaking about citizen science, I'm reporting also about this experience where there were babies and elders and so on, all collaborating together for building this map. And this is something that Professor Furuhashi has been doing for many years in the past, but now also is very active in this field. And specifically, in the beginning, the idea was to make this collaborative mapping using OpenStreetMap, but then he started also working with drones and providing new solutions and new methods and new procedures related to the drones and how people can use drones for collaborating in building these collaborative maps. I'm very fascinated by the way of Professor Taichi in proposing a new solution going toward, we can say, democratization of maps. We know that maps are relevant for many, from many point of view. They are relevant for planning. They are relevant for deciding how to change the city, but they are relevant also for monitoring and controlling also the cities and the place and the environment. So it is very important that maps are owned and are built by people. And what Professor Taichi is presenting today to us is something new. So it is the possibility of putting together the images and the pieces of information, data that are available on the web for building something that is relevant for understanding what's going on, specifically in this very difficult period, in the period of the war, for being able of distinguishing between what is fake and what is true. So I'm very happy of having you here, Taichi, and I'm looking forward to learning something from your presentation. Just to say a few words about Professor Taichi, more professional, because I presented him more as a friend than as a professor, but Taichi is also a professor of the Aoyama Gakuin University, and is also president of the Crisis Mapper of Japan. Recently, he started a drone bird project with drones for the disaster crisis response. So thank you so much, Taichi, for being here, and I will give you the word now. Thank you.
Thank you. Thank you for sorry. Thank you. Thank you for introducing about me.
I made you as a presenter so you can share your screen and start the presentation.
Okay. Share. Can you show? Okay.
Yes, we see it. Yeah.
Okay. Thank you. So, yes, my name is Taichi, and I work at Aoyama Gakuin University in Japan. So, yes, already Maria said, so we have many years collaboration. Yes. And today I like to share about our knowledge and experience about Ukraina's situation. And today we have, I think, about 30 minutes until the yes, maybe about 30 minutes. So today I would like to our technical geospatial data sharing method, and mainly now we are publishing or sharing satellite imageries and also drones data set mainly as 3D point cloud or 3D model data on web mapping viewer. So the purpose is about for the geo intelligence. So Russia's invasion situation. So many satellite imageries provider shared state of the Ukraine situation. So, and we can understand and we can confirm what happened, what is real. So, and sometimes we can confirm and we can compare if this information is fact data or fake data. So we have to divide, we have to get more correct data, and we can check and we can confirm using by geospatial technology. So today I would like to share our knowledge for those purposes. And first, yes, that is my Twitter account, and if you have some interest, maybe today is a very short time, so maybe I cannot explain all method and information. But many times we can communicate. If you have some questions, so times you can send to my Twitter account or Facebook or other SNS account. Yeah, keep in touch. And also, yes, I main work is I'm a professor at Aoyama Gakuin University, and my facility name is Global Studies and Collaboration. That is our facility's name. And many times I have to teach about how to use geospatial tools and how to make geospatial data. And I teach many classes at the university to help students handle where, where, where that information is very important, where information correctly. So sometimes we can use QGIS or OpenSmap, Google Earth. So we can use those very good tools. And also, maybe you know where that information means. Example, latitude and longitude data, or other projection data as X, Y, or Z. And of course, addressing data or zip code is a geospatial data. And so satellite imagery and drones imagery can be defined as raster data. And of course, we can make map data as a line, point, or polygons as vector data set. And now we can use three-dimensional point cloud data too, provided from drones or other photogrammetry method. And we can make 3D model using by 3D CAD tool. And another thing, so we can use 360 degrees panorama photo data. So anyway, where information, geospatial data is a very diverse data set. And but many times I have to teach where this information is very important and how to use and how to make those data set. So, and So my experience, so I'm collaborating with Open Geospatial community, of course, OpenStreetMap, Mapillary Open Area Map, Humanitarian OpenStreetMap GHOT, or We Robotics, Flying Lab, Youth Mappers, UN OpenGIS, or Dronebirders, NPO in Japan, or OSGeo2. Yes. So those open geospatial community is very important for me and my students. So many times I said so to my students, so you have to contribute or you have to make this data, you have to use this tool. So yeah, this is my main work and our collaborators. So, and example, I for the OpenStreetMap community, so I'm OpenStreetMap mapper since 2008. Already I have 14 years history. Yes, and this is my experience in the mapping for countries. So totally I contributed for 62 countries. So like this. So of course, Japan or other countries. So I work with Brazil government side for the detection, the deforestation, illegal deforestation using by Japanese satellite data or something. So maybe you can guess. So I work with many countries. Yeah. And this is my experience on OpenSmart. So yes, yes. Many years so we work with community and we work with tools and yeah, sometimes I'm addicted mappers on yeah, OpenSmap too. Yes, and also yes, now we are collaborating with domestic Japanese drones community. We own drone like the VTOL type or fixed wing type of drone. So those drone can cover huge area, and we can take a lot of area photo data, and then we can calculate the three-dimensional point cloud data, and we can convert to the 3D dimensional voxel tile data. So anyway, many times we can share, we can make data, we can work with open geospatial community. And today, I would like to share about the 2022, this year's Russian invasion of Ukraine's situation. So maybe you know that is a very serious situation, continued, renewing. And that, so day is February 24th. So that crisis happened. And I remember, so yeah, this situation is very serious. And how to help and how to collaborate the geospatial community for more good work. So, and I searched many information on the net, and next day, February 25, so I found satellite imagery provided from Planet. So Planet had the gallery's website, and this gallery website published the Ukraine situation data. So, and I found it February 24. So Mikola Live Air-based imagery provided from Planet provider. And I confirmed, okay, this is published data. And so, and what is this license? And I confirmed, this airbase, we can slide and we can compare time series. So before Ukraine's crisis and after that. So, and we can compare and maybe we can find some creator or something. Anyway, so and we confirmed this data license is Creative Commons CC by NC non-commercial. Okay, we can use for non-commercial purposes, and we can use for second uses. So and this step, so I understand where is this airbase. So, but planet data is only image data set as a JPEG file. So there is no georeference metadata, and I cannot understand. So, okay, I have to confirm correct place and correct position. And but planet companies they provided only image file, JPEG file. So where is Mykolaiv airbase? And so this georeferencing process is a very traditional but very important process, I think. And I used Google Earth for georeferencing. And I defined correct latitude, longitude, and rotation metadata defined by KML data format. And also KML data format can find raster data, vector data, or 3D model, a lot of data KML can define. But I chose, okay, ground overlay definition is better. So I added using my Google Earth Pro standard tool. And I make JPEG file and KML metadata set, and then I convert it just one KML zipped file, KMZ file. So, and after that, I published because Planet Data is a Creative Commons license. I can publish, and I post on my Twitter account, and I defined correct position with KML dataset and JPEG file, and I composed just simple one file, and I uploaded this file into the GitHub platform, GitHub repository. So I'm sorry in Japanese, but maybe you can understand. So this thumbnail image is a Google Earth screenshot, and I add the JPEG file as just one layer overlaid, and I defined correct latitude and longitude and rotation. So I made this data set, and I compared before Ukraine's crisis and after that. So, and the damage situation we can guess. So, okay, this is a very serious situation. So this is a individual activity, but my Twitter post published, and of course I uploaded my KMZ file, KML and JPEG file. So that file published on GitHub repository. And if you want to use, and if you want to download, you can access to my GitHub repository, Ukraina 2022 data, that is a correct name. And so like this is my GitHub repository. So many times when I found new satellite imagery, I add georeferenced metadata, and then I made a KMZ zipped file and uploaded to my GitHub repository. So, and now every day I'm archiving a lot of data set on the GitHub repository. And so this is my individual activity. But my friend, the Tokyo University's professor, joined my activity. So his name is Hidenori Watanabe. So, and this is the second day, February 25. So, okay, your KMZ file is very useful. I can publish and I can post this data onto cesium ion. So that is a kind of web mapping viewer tool. So like the Google Earth, but general user can use only web browser. So very useful tool. And he has a very good experience, and many times we have to collaborate it as a project. Anyway, so my KMZ file moved to the Cesium Ion, and we can use this our data on the just one web browser. I can show. So this is a Cesium Ion, and this is like the storytelling GIS. So maybe that is a very famous tool. So and Cesium is an open source web library, and if we uploaded a lot of data set into the Cesium Ion, so we can add some stories like the storytelling GIS, and we can change each data. So this data is satellite imagery taken on March 9th, so end of March. So this is close to Mariupol city, very serious city. And so satellite imagery can explain. So there is a mass grave, and many people can guess how many killed. So that situation is, so maybe we can confirm that is a fake news or real news. So many people have to check, and so this process and this data can overlay other data, and of course we can compare the Google Earth or other source as a satellite provider. So we can search, we can archive, and we can get a lot of sources, and we can check based on those web mapping tools. So this is another place of mass graves. So yeah, every day I'm checking, and I'm adding correct georeference metadata, very serious. But so this is a very real situation. So I have to share. This is a real, not fake. So yes, I want to explain. So yeah, this is the first data, February 24, and so now we are collaborating two approaches. So one is making KMZ dataset based on Google Maps, Google Earth, and also data sharing platform based on GitHub. So, and also KMZ and KML format have the interoperability. So of course QGIS, ArcGIS, or other GIS tools, and also Cesium Ion can import KMZ file. And Professor Watanabe, he can publish our data onto the Cesium Ion, and the tool can show and share via the web browser. So this combination is, I think, better. So, and yeah, in my opinion, so if we want to collaborate for more platform, so I think that is a very good example. So I tried Google Earth Web tool. So Google Earth Web has a Google Earth Web project function. So sometimes Google Earth can define like the Cesium Ion's storytelling tool, but so recently, so latest version of Google Earth Web tool cannot publish using by KMZ imageries. That is a recent problem. So and already I had discussed with Google Earth team, and okay, Taichi said your opinion is correct, but still we cannot provide that the storytelling GIS for the satellite imagery. So yeah, but I hope so we should collaborate with more good tool. So, and those diversity is very important, I think. Anyway, so now we are using Google Earth Pro and also GitHub. Another thing is Sejumi. So, and so after that, we searched from via the SNS or website, and so Planet, Naxa, Sentinel, Black Sky, and NASA or Kepler Space. So a lot of satellite imagery provider published from direct or via some journalist or media's platform. Anyway, so if we find new satellite imagery, so after that, I redefined correct referencing metadata, and then so I republished KMZ file on the GitHub, and also Professor Watanabe team published our data into the GitHub, Cesium Ion, and now. So we are using satellite imageries, and also sometimes good three-dimensional model data or point cloud data sharing on the Sketchfab platform. That is a 3D modeling data sharing tool, and so yeah, Ukrainian people or other foreign countries supporters, they can get drones video or other data set, and so they or our side we can calculate, analyze photogrammetry method, and we can get three-dimensional point cloud data and 3D modeling data using by Metashape or other SFM tool or blenders like the 3D CAD tool. And so now we are getting three-dimensional data from Sketchfab, or if we can find good drones video or other source, we can analyze directly, and we can make three-dimensional point cloud data or 3D model data using by those tools. So anyway, we are mixing and we are archiving. So today we have a very short time. So I have to share about the technical things. So how to georeference using by Google Earth. So that is a very traditional remote sensing method. But so if you want to try, that is a very difficult, I think. So I can show. So now we are using the reference data is Google Earth. So because that is a very useful and free, that only that viewing is very free access. And also we are collaborating with Google team too. And many times we are discussing, and sometimes licensing problems happen. So, and already we said, so this is a fair use. So we want to use georeferencing based on Google Earth Pro. So that is no problem. So many times I said to Google side. So anyway, so example, Reuters, that is a very major media, and Reuters said, shared those satellite imagery provided from Naxa. And Reuters said that place name is Stoyanka, only a place name, without georeference data, latitude, longitude. I don't know, Stoyanka, where is. And so I checked, I confirmed this is a Naxa's imagery. So, and destroyed bridge at here. And so maybe we can guess and we can understand many information from this imagery. And what information can you display from this image? So can you prove that this image is not fake? So we want to confirm. And does it real exist? So maybe you can find there is U-turn bridge at here. And this is a parking area, parking lot. And maybe you can understand and we can find this shadow direction. So maybe we can guess direction of solar radiation is from the upper right corner, so this direction. So maybe you can understand. So in Ukraine, so this satellite image shows the north-south axis reversed. So let's check if this place is real with Google Earth. So this is a Google Earth around the Stoyanka. So maybe I zoom in, so maybe you can find, oh, there is U-turn bridge. So maybe we guess this is a satellite imagery position, but maybe you can confirm. So same U-turn bridge. So you should compare with Google Earth. This is a Max's imagery. So there is U-turn bridge, and there is river, there is a road, and there is farmland. So land use and geospatial object, geofeatures exist in this imagery. And of course, the direction. So north upper's image is like this. So, and let's back to Google Earth. So let's check. Okay, there is river, there is road, there is farmland. So this component is like this. And I defined, okay, this is correct position. So, and I defined geospatial metadata like this. So maybe you can understand. So the reference data from Google Earth side, so that data doesn't have U-turn bridge. So there is no U-turn bridge, but Max's imagery has U-turn bridge. So because latest Google Earth base image was taken in 2019, very old data. So yeah, sometimes that problem will happen. So we can guess and we can find correct position. And one more thing. So this is another Max's imagery. So, and destroyed by the Russians armies, this building. So, and of course, we can confirm direction of solar radiation. So, okay, north up is this direction. And farmland is here. And the building is located on the west side of the farmland. So this component, so we can understand. Okay, and so this Maxa imagery, so media said that image at the west of Chernihiv, only this information. I don't know where is west of Chernihiv. And but Chernihiv is here, so this city name. And the west side is, I think, here. So, and but I have to find correct position. So west parts is buildings area, and east parts is farmland. So we can adapt. So maybe this one, this one, this one, and we found here, so like this. So very simple and very traditional method, but very difficult works. So, but we can find. Oh, okay, this building exists in at here, and that data is not fake news. So, actually, this crisis situation happened in real world. So, location identification using by geographical analytics method. So it is then georeferenced and published as KMZ file. So every day, every morning, I found new satellite imagery, and then I defined, I have to find correct position, and I have to define just referenced metadata, and published. So of course, the satellite imagery company provide the imagery with location information. So of course, Maxa, Planet, and so they are providing geospatial metadata to news media or journalists. But so, however, since general media and journalists report story, but don't place importance on location information. General news, general stories is circulated on SNS and in the media without the where information that has been given to them. So yeah, this is a problem, but we can add correct georeference data, and many people understand. So this situation is very serious, but if this data is fake news, so we can
Hi.
oh, sorry,
Very serious battle.
my three happened. Wait. Okay, and yes, first I have to georeferencing, and after that, so we can get many series data set, and we can compare comparison for the time series data set. So this is a example. So yes, I said sometimes there are mass grave site around Mariupol or Bucha area. So anyway, so we can compare the this month, last month, or so we can check from the Maxa side, planet side, the multiple sources and multiple time series. We can compare. This is a real information and how many people killed. So correct georeferencing process can make those time series comparison system. So yes, so this is a very simple method, but georeference process is very important. So now we are archiving and we are getting a lot of satellite imagery. Sometimes Maxa side and Black Sky provided good information now. And so now we are collaborating, network is extending, and now we are getting our other three-dimensional data set from Sketchfab or other SNS community. So I think, I hope so. Please stop and please end of this Ukraine's crisis situation. So, but that situation is continuing. So we will archive. We have to archive more variable data set. So and last information. So how to join to our project? So very simple. So every day, every time I shared our data and our method using by this Twitter hashtag Ukraina 2022 GeoInt. So and if you find new satellite imagery from the journalist or media, so please share. I found this imagery. So maybe after that I can add correct referencing data and republished. So and if you can add and if you can make georeferenced imagery, so please share your data so we can add your data into our GitHub repository and also Cesium IO. So very simple. And if you have some question, please connect to my account or our hashtag. We can collaborate and we can exchange our knowledge and our technique. Maybe Google, Cesium or other open source tool or geospatial community supporting for our project. And also satellite imagery provider can support. So we can make and we can make more better society in the world. So thank you.
Thank you, Taichi. A very clear explanation about your methods and your results. I think if also Maria agrees and Taichi agree, I can make my very short presentation and then give the speech to a round table for questions and comments and other things. Is it fine like that? Okay, so I move myself as presenter. I share my screen. Can you see my screen?
Yes.
Okay, so the purpose of my very short speech is to explain where and how students can learn about geospatial information with a specific regard for Politecnico di Milano, clearly. And Taichi gave a very clear explanation of one possible application of geospatial data. More in general, what is geospatial information? Simply data with coordinates in space and also in time. Remember, now we have time series typically, but the general name is geospatial information. The sources are from the very beginning in situ sensors, for example, meteorological sensors. And mainly, I'm just focusing on the main data sources nowadays that are observation from satellite to Earth, and also in certain cases, observation from Earth to satellites. Here you see an example in false colors. This is Pianura Padana, and this is a specific representation of one image that gives us an idea of the vegetation status. The original goals of geospatial information were unfortunately military, because this was the first purpose. More fortunately environmental, for example, land planning and management. But at the present, the boundaries have moved. Geospatial information is used for the monitoring of climate change, for example, for mapping purposes, for many commercial applications. Just for one example, the fleet management, fleet logistics. Indeed, you see here a picture, again in false colors. It is not a picture as we intend. In this satellite image, ships are identified in the sea. So the purpose of this particular image analysis is to identify ships in the seas. Several data sources for geospatial information, but actually Earth observation is the main at several scales. Earth observation from satellites, Earth observation from drones, photogrammetry, and so on. And so what is the teaching offer of Politecnico di Milano about these topics? Okay, I just remember that in Politecnico Milano we have 28 bachelors, 42 Master of Science, and several study programs that can be related to the topic of Earth observation. And which kind of expertise for Earth observation? Because if you are interested, for example, in the space segment, I mean satellite mission planning, design, management, you have to study for sure space engineering. If you are interested to the problem of the data acquisition for the sensors, data transmission from satellite to Earth ground stations, you have to study probably telecommunication engineering and so on. My next 4 slides are focused on the specific topic of geospatial analysis of the acquired data. To explain, I want to make a very short consideration. Geospatial information has experienced a disruptive evolution in time, both on data and on processing techniques. For example, the first satellite missions for remote sensing was Landsat in the 70s of the last century, and Landsat provided images with a spatial resolution at the ground of 80 meters and a temporal resolution of 18 days. Temporal resolution in satellite missions means the time needed to revisit the same area of the Earth surface. Nowadays, missions have a spatial resolution that are better than 1 meter and temporal resolution better than 1 day. So we have continuous time series with very resolved images. Moreover, also the provided data passed from simple idea to complex ideas. I mean, in the 70s, we had just multispectral images, so something that is like images we are used to acquire with our cameras. Now, satellites provide other kind of images, hyperspectral, synthetic aperture radar, for example, spectrometers, and so on. So we have different kind of data that we can analyze, not only images. And also the processing techniques have experienced evolution. I always mention to my students this very simple example, classification. In the 70s, a very refined for that time method to classify images was k-means. I can guarantee you this is not the purpose today. I want not to explain you k-means, but I can guarantee you that in my lecture I can explain to students k-means in less than 2 hours, and they perfectly understand k-means. Now, machine learning are used that require courses to be understood completely, not one lecture, really courses. Processing techniques has really evolved. So, in such an evolution, what are the needs for an expert in geospatial information? An expert in geospatial information must be interdisciplinary between geomatics and computer science, because he needs geomatic basis about the acquisition of the data, the validation of the data, classification, storing, and so, up to the geoservices. But on the other hand, to be really an expert, he needs to have strong basis in computer science, because he needs to know the computing infrastructures, he needs to know software engineering principles, he needs to know databases and big data, and so. So the figure is now interdisciplinary between geomatics and computer science. So let's go to our Master of Science in Politecnico di Milano. I am the chair. The Master of Science is named Geoinformatics Engineering. And actually, it is the first and only one in Italy. And I have to say that is quite innovative also in the European scenario, because we are forming exactly what I've just said. We are preparing experts in geospatial information that are interdisciplinary between geomatics and computer science. Just to finish, I have to mention that the Master of Science is international, with a strong presence of international students. And nowadays we have classes of about 30-35 people, so small classes that make easier also the interrelation between professors and students. And if you need more information, you can write me an email, or you can collect at the website of Geoinformatics that is listed at the bottom. So I have finished.
Thank you, Ludovico. And then thank you a lot, Taichi, for your presentation. The project is really interesting, and I believe that it will be even more interesting if more people want to collaborate. And that is definitely something that is really important, to have the possibility to monitor really what's happening around. I want to see if there are questions from the floor. If not, I have a first question. My first question is this one, because you mentioned more obviously high resolution images, like the planet or the maxar. So images that unfortunately are not available free of charge. And even if you want, it's impossible to buy just one image. You have to buy a large quantity of images, or to make a subscription, making it very difficult from the economical point of view. So my question is, did you also try to see if it is possible to use the open middle resolution images, like I'm thinking about the Sentinel images, Sentinel-2 or also Sentinel-1, because I believe that, for instance, for checking the building that are destroyed, the Sentinel-1 can be also excellent, as a matter of fact, or other open images that are available. Did you already try to use some of them, and what are the main limitations?
Yes. So yes, great, good question. So yeah, high resolution data provided from Planet or Maxa, and also yeah, Sentinel-2 or 1. So that is a middle resolution, but that example Sentinel-2 is a daily data we can get as open data, and so we tried. Of course, Sentinel-2 cannot detect that the building's damage, but we can detect, example, the fires or high temperatures area. So around Mariupol or other cities, so we can calculate and maybe wait a moment. I can. I
Because
will
I'm
share
thinking
my.
that we have also a teaching in Earth observation,
Mm.
and for sure using these Sentinel-2 images, students can check, as you say, where there are fires, for instance. That can be a hint about bombs there.
Yeah, that is available. So recently, the Ukraine's east side and south side now Russian troops attack is continuing, and yeah, Sentinel-2 can detect those the bomb or fire or some serious situation. Very high, low, middle resolution, but yeah, we can detect. Yes. So yeah, if your student can analyze. Yeah.
Do you have some examples?
Yes, we have many samples. Example. So
Do you want to show something? Do you need I make you presenter, Taichi?
go on. Now, if I can share my screen so I can show our example.
I think I have to make you presenter. Let me.
Yes, Ludovico.
Okay, now you are presenter. You can.
Uh, Sorry, wait a moment. I will check. This is a high resolution. And this is a low resolution provided from, this is a NASA's satellite imagery. And so sometimes this is a Mariupol's fire detection. And this is a Sentinel-2. So maybe you can find very huge size of fire attack like this. So we can detect.
Yeah. Yes, and using also the different bands is possible to find the burst areas. So it is something that can be done enough easily to be put in the archive. Yeah.
Yeah. So Sentinel Hub is a very good tool. So we can use, and so maybe this tool you can set the day or which type of data. So this interface and this analyzing tool, so very useful. So maybe your student, so they can
Yes.
Yes, yes.
Yes, this platform, EO browser,
EO
is
browser, yes.
available free of charge for students for the educational purposes.
Yes.
So it's not a commercial one. So if you want to use it for work, you have to pay. But for university is made available free of charge, and it's a very good solution because it's very easy to be used. It doesn't require you to be an expert, as a matter of fact. And it is also guided in the meaning that it's possible to obtain many combinations of the different bands for better studying some characteristics, like for instance, the fire presence.
Yes. I add this permanent URL permalink on the chat, so maybe
We see. Yes.
try. Yes, please try.
Any question? Don't be shy.
Yes, please.
Okay, there is a question in the chat from Madeleine, our student.
Do you want to read the chat?
Yeah, I have a question about the technique you use to identify fake images. The technique you use seems designed to spotting only images that are made out from scratch, so of which the topographic features doesn't exist. What about a fake image that would be based on a true satellite imagery but modified, for example, in Photoshop? How could you detect that this image is fake by this method? And if it is not possible, what other analysis methods do you use to detect this kind of fake images?
Yes, good question. So my answer is, so multi-sources is very important. Example, if that situation explained only Maxar imagery, so that is very difficult for the confirming. But if planet imagery, Maxar imagery, and other Sentinel or other sources explained the same situation, and also if we can add from the ground level data, from the journalist video or drones imagery or some photo data, so we can combine and totally we can check this is a fake or not. So yeah, multi-sources is very important. And also in addition, so time series process. So when this issue happened, or so maybe the best situation is so yeah, constellation satellite imagery data set, but maybe we can compare for the time series. So past data, recent data. So those multi sources and time series data set can maybe check and can define this is a correct data or fake data. Just only one source data, that is a very difficult. We cannot confirm. And now, yeah, internet media is has a good so data sources, and sometimes another OSINT community. OSINT means a open source initiative community. So they analyzed journalist video. And this situation happened at here, and they shared the correct their guest estimated latitude and longitude, and then I received this information, and I composed our size satellite imagery and overlay, so we can confirm. Yes.
If I may add, this problem that was posed by our student. It's a very relevant one, as a matter of fact, from Madeleine. It's a very relevant one. There is not a unique solution, and it is for sure one big problem, because in fact there is the possibility of creating completely fake um, pieces of image using the surrounding and changing changing some details as we please. And from that point of view, from the point of view of GeoInt, I have to say that we are in the beginning. So being able of evaluating the quality of the image with respect to the fact that they can be partially built for making them fake images. It's something that was already important in the past, but now it is appearing more and more important. And there are many research teams that are starting working exactly on this topic. And so there are no clear answer now. There are more questions about fake maps, fake geospatial data, fake images. There are some attempts by some organization in order to certify the images they are providing. And for sure it is something that will be studied in the future. And so pay attention that this can be a good research topic, as a matter of fact. So not only something useful for the humanity, but also from the point of view of research is something that is very relevant. And so pay attention to that.
Thank you. And I think technical side, so photogrammetry method is a very good approach, I think. So I will share. So now we are analyzing not only satellite imagery. So we are getting three-dimensional data based on photogrammetry method. Method. So if so fake data exists, that photogrammetry processing. So I guess 3D 3D data can explain. So example, there is a destroyed car at here, and so we can check, and actually this 3D shape is correct or fake. So only two-dimensional data. So sometimes Photoshop can add some fake information, but three-dimensional approach, so we can check as a geometrical approach, and yes, this is a actual 3D series. Data is slow. Yes, so satellite imagery and drone or other three-dimensional photogrammetry data. So this data can check, and the process can find fake data. So this is my idea.
And Taichi, there is
Yeah.
a question from Vasil Giordano saying, in the beginning you show 3D models of demolished buildings. What is the source of the images? And second question, if there are platform on the collaborative principle for UAV, for UAV tasking, similar to the hot tasking manager? Those are the two questions of Vasil.
Okay. So the source had two types. One means provided from Ukrainian engineers, so from by directly. So sometimes I very sad. So very famous drones pilot killed by Russian army last month. So, but Ukrainian engineer and journalist can use own drone and they can detect, and after that they can share as video or photogrammetry data set to OSINT or GeoINT community, and we can receive. And the second process is only the video via the journalist or media side. And many times they published their video from drone or other from ground side. Anyway, that video published via Twitter or Telegram or other SNS, and we can we can receive those video without geolocation data, only video. But we can calculate, we can analyze photogrammetry tool using by Metashape or other tool, and we can get three-dimensional point cloud or 3D model data on my PC or yes, our drone batch. So we can get two sources from Ukrainian engineer or general media via SNS. And the second question is, so if we want to publish, we want to collaborate the UAV tasking, so still, oh, yeah, if we want, now recent tasking manager can define only the block, the cell. So recent photogrammetry processing depend on each sources. So if we find video from the Reuters or other AFP or other major media, so we can download as just one video file, and so still we cannot divide the tasked area, and that is depend on that each video sources. But I think Sketchfab platform is a very useful. Many times, so Ukrainian engineer or other OSINT community published on 3D model data or point cloud data into the Sketchfab platform. So if we can share the request area or something, so maybe that is very difficult. So there is no the UAV tasking system like the tasking manager, but so yes, still we work based on depend on each source video data. But so if we want to extend this tasking system, I think, in my opinion, so Mapillary has a Mapillary marketplaces function. That is detecting data target. Sorry, data detecting target area matching process platform. So so anyway, if some company some organization want to get mapillary data set, so they can pay the target area or priority, high priority area. So, and then mapillary marketplace can share those priority area, and some user want to join to this high priority area, so that user can get some little budget from company side, and so those matching process, if that process can work, for example, we can donate some budget to Ukrainian engineers, and then they can take drones imagery, and they published those data to those matching platform. Maybe the system will work, but yes, this is very difficult. So, but the idea
Yes.
is very good.
Yeah. Yeah. Thank you. So are there the last question, because it's late, so it is more than 1 hour. So is there a last question?
Yes.
No, I see none in the chat, and I hear none. So, oh yeah, there is one more question. Goritza asking, you showed an example of the detected mass grave from Maxa and Planet. I would like to know what are the clues, your clues, that it is graveyard and not some other feature like field for crops. Is there a particular characteristic that tells you it is a mass grave or not something else?
Yes, yeah, that is a very good question. So, yeah, my answer is, of course, training data. So on the ground is very important. So, example, in Bucha situation, so the Max and Planet satellite imagery detect, but other sources from the ground side. So journalists take a photo or video, and of course, so sometimes high resolution data from the drone imagery. So yeah, only satellite imagery. So we can not analyze the mass grave details. So only the cropping, farmland or something. So yeah, that is a very difficult. So we should add not only satellite imagery, we have to add more other sources, other resolution, and other data sources. So that question is a very good point, I think.
So it means that it was not only done using satellite images, but there were added also other pieces of information taken locally.
Yeah.
Okay. Okay. Thank you so much. So I see that there are no other questions, so I want to thank you so much. But then I leave the last word to Professor Biagi for closing this very, very interesting webinar. Thank you, Taichi. Thank you for your work and your presentation as well.
Yes, thank you, Taichi. I have no more things to say. We have heard a lot of interesting things today. I want to talk to thank also the participants, that we had many participants, and I think we have to leave Taichi to go for dinner, I think, because if I correctly understand, it is 9:30 a.m. in p.m. sorry, in Japan. Is it right?
Thank you.
Okay. So thank you again.
Thank you, and see you for the next webinar, or here in Italy, possibly at the